This last section is going to be talking about polynomials, where now we get into variables with exponents and all that kind of good stuff. And so when you have one of these polynomials, notice that whatever the value in front of the variable, so let's say I have 3x squared minus 5x plus 7. This number, that number, and even that number are called the coefficients. So typically we say the coefficient is on the variable, and you might say, but that one doesn't have a variable. I could put one, right? X to the 0 equals 1. So just so that kind of makes sense why that works. The highest power is the degree. So in this case, this would be a degree of 2. And then you have different, let me do this, minus 5x, and then of course what I had, x plus 7. This would be a monomial. This would be a binomial, 2. This would be a trinomial. And then after that, we just call them polynomials. Okay, so to be able to go through these. Now, what you'll start to do with these is you will learn to collect like terms by, say, adding. So let's say I had something like 6x plus 9 plus 3x plus 2. You are looking for, do it with the 1 in there. You're looking for common terms, meaning that they have the same power. And so in this case, I would just add 6x plus 3x, which would be 9x. And then I would add these two constants, 9 plus 2, to get 11. And the only time you really want to be careful is, of course, with negative signs. Before I go to that, let me do another one. I see negative 7x plus 4 plus negative 4x squared plus 7x plus 3. A lot of times when students first learn these, they put them in like columns based on the power. So I see I have a squared. So of course this is a degree of 2. And now I see I have a minus 7x, and here I have a plus 7x. And then I have a plus 4 and a plus 3. So I would get negative 4x squared. That cancels. And then plus 7. Just kind of popping through your problems. So when you want to be careful is with negative signs. So if I have something that looks like this, you need to be sure that you distribute that negative to everything inside the parentheses. So that's really 3x minus 6x. A negative and a negative would be plus 3. These are my common terms. One is positive, one is negative, so I'm going to subtract and keep the negative sign on the larger value, and I get that answer. As you continue along with those, what comes up next will be doing some multiplication. So if I have 4x and 3x squared minus 5x plus 5, you'll see this is where your exponent rules come in. So I'm going to take this 4x and multiply it by everything inside the parentheses. And so 4 times 3 is 12. X to the first power times x squared with my exponent rules, that would be 3x1 plus 2. And so now I'm going to do the next one. 4 times 5, negative 20. X times x, x squared. And then finally the last one, 4 times 5, 20. And then I'm left with that x. You'll then get into multiplying binomials. How do I know this is a binomial? Because there are two terms. This is one term and that's another term. With binomials, they use what's called FOIL, which says multiply the first terms, then multiply the outside terms, multiply the inner terms, and then multiply the last terms, hence where they get FOIL. So the first terms is x times x, and then plus my outside would be x times 6, and then my inside 5 times x, and then finally my last 5 times 6. So this would be, that's like saying the first power, so 1 plus 1, that would be squared. 6x plus 5x plus 30, and I think you have common terms here, so this would be x squared plus 11x plus 30. Just kind of picking some more problems out here. So once you get through multiplying, if you have something like, let's say 2x minus 7 squared, you have to be careful because that means 2x minus 7 times 2x minus 7. Okay, you can't do that rule where you bring these values inside or you're going to miss the middle piece. So if I FOIL this, 4x squared minus 14x minus 14x, and then plus 49. And in fact, later, as you get doing these, minus 28x plus 49, you will see anytime you square something, you square the first term, you square the last term, and you take 2 times these two terms multiplied. I mean, that's what's happening here. If you're like, wait, what? You'll get to that as you continue to do these. And I believe there's a couple of, yeah, there's some, let me get a new slide here, some division. So I have 17x to the 6th plus 8x to the 4th over x. You have to be careful because this is really doing this. You can separate these like that. And what I mean by being careful is students sometimes will say only cancel this with one of those, but you have to be sure you're doing it with both. And so if I use my exponent rules, this will be 17x to the 6 minus 1, because it's like a 1 there, plus 8x to the 4 minus 1, which is 17x to the 5th, plus 8x to the 3rd. And like I said, as you get doing these, you'll get quicker. You'll just say, oh, 5 and 3, and canceling that way. But just be careful on these that you don't, accidentally only cancel one and then not cancel the other. Let me do one last one here. This one looks pretty good with a negative. So it says 15x to the 4th minus 10x cubed plus 7 all over negative 15x to the 4th. Whew, that's a doozy. So I probably would write these separately. I mean, you can separate them like this. And so then I have minus 10x to the 3rd over negative 15x to the 4th. And then plus 7 negative 15x to the 4th. So this first piece right here, I certainly see the 15s are going to cancel, and look, that's going to cancel. But I still have a negative, so I really have a negative 1 here. And now this piece looks like I could divide out 5 in the top and the bottom. And then it looks like 3 minus 4 would be a negative 1, or these 3 are going to cancel and make that a 1. So it looks like, what do I have left here? I have a negative and a negative, so that's going to be a positive. On the top, I just have a 2. On the bottom, looks like I have 3x. And then I don't see anything here that I can do with that piece.